Welcome to Foundations Are Us, where we build knowledge from the ground up.
Welcome to Foundations Are Us. Today, we are focusing on construction notes and how they translate into the real-world building practices. We will be working with Lot 75, using it as a practical example to reinforce, to read, and apply these details with confidence. Foundation basics, footings, and walls. Let's begin with the fundamentals, footings and foundation walls. In low-rise residential construction, foundation walls are typically poured in 6, 8, 10, and 12 inches in thickness. For your standard typical footings, your width is typically 20 or 22 inches wide by 6 inches deep, and they will increase to anywhere between 24 to 26 inches wide up to 9 inches thick, depending if it's a 3-story town or a walkout basement. Typically, these measurements, though, are typical for all walls up to 10 feet high. However, conditions vary. Poorer soil condition, over-excavation, or site interference might just require adjustments. The principle is simple. Greater loads require wider base to maintain stability. Concrete strength and wall preparation. Foundation walls are typically poured around 20 MPa in strength, even though the minimum code is 15. After the pour, the process includes stripping the forms, patching imperfections, applying exterior damp-proofing, and sealing all tie holes. Each step is critical for durability and moisture protection. The drainage system. At the base of the footing, a 4-inch perforated weeping tile is installed. It is wrapped in a filter sock. You'll see this black sock that runs around a black pipe, and that prevents fines from getting inside that pipe, so it will no longer clog in the future. The system runs around the entire house, along the exterior walls, inside the garage walls, and through the porch interiors where required. So if there's a cold cellar, it would be ran on the outside of that foundation. If there is no cold cellar, it's run on the inside. So essentially, the weeping tile follows the warm zone of the home. Once the weeping tile and the drainage layer is installed, we apply 6 inches of 3/4 crushed clear gravel on top of the weeping tile to protect it, not only from being crushed, but also for water to drain through properly. This also ensures drainage and protects the foundation from water infiltration. Soil conditions. All footings must sit on solid, load-bearing soil. The minimum requirement is 75 kilopascals or kPa, and we're looking for 150 kilopascals or kPa. This is better to build on. The essential is long-term performance. Green build features. This project included a 4-inch rigid insulation layer beneath the slab. This provides an R value of 5. The result, an increase in floor temperature of an approximate 8-degree difference, a measurable improvement in comfort. Anchoring and structuring connections. Anchor bolts must be installed at a maximum spacing of 6 feet. This is at the top of the foundation wall that will hold the sill plate down and anchor it to the top of the foundation wall. And then no more than 2 bolts per section. So if you have a jog, say for example, a garage jog that comes in 2 feet, you need a bolt on one side and on the outside. So one on each end. So then that way the plate can be anchored down. Can't just have one in the middle. Any voids, gaps after stripping must be filled with non-shrink grout, and there's no exceptions. Load points and pads. Load points require properly sized pads. Standard pads typically are 34 by 34 by 16 inches. Heavier load pads are 42 by 42 by 18 inches. These transfer structural loads safely from the roofing system down to the solid ground below. Beams, nib walls, and support. Beam pockets and nib walls are typically 8 inches by 8 inches. Beam pockets require a minimum of 3.5 inches of bearing. These elements work together to transfer loads through the structure. So you would have the load coming down on the foundation wall on one side. It would transfer over to a column pad in the middle of the unit and transfer down to the pad and release pressure in the middle of the home that way. And the beam would continue to the other side of the home into the pocket and transferring load down to that side of the wall. And then dispersing the load evenly from the roof all the way down to the footings. Garage structure. Garage slabs are typically 4 inches thick, 32 MPa in concrete, so that's megapascals, with air entrainment. Air entrainment allows that garage to harden up even more than regular concrete. Wire mesh or fiber mesh is also installed, and we use grade beams under all of our garage slabs. So a single car garage will use 2 grade beams. They're approximately 8 inches by 8 inches, and they're 45'd. And they will have steel inside them. They get bolted and drilled into the foundation wall, end to end. And then they will get poured into that concrete that gets done on top of the slab. You'll never see it. And it acts as an anchor to not allow that slab to fail. On a 3-car garage, you'll have actually one running right up the middle as well. So you'll set the 2 that are side by side, call it horizontally, and 1 vertically. Stairs and step conditions. Precast steps are limited to a maximum of 3 risers, with a maximum of 200 millimeters or 7 7/8 rise. They should probably be only used in protected conditions. If the slope is too steep, a custom wood stair would be required to be built. Step footings. Step footings are critical on sloped sites. Minimum horizontal step, by code, is 600 millimeters or 24 inches. They must follow the angle of repose. So what the angle of repose is 1 to 1. So every 12 inches you go up, you have to go 12 inches over. Code allows us to go up 2 feet, so we're allowed to go up 2 feet. And then we have to go a minimum more over 2 feet. We can go 3 feet or 4 feet or 5 feet going horizontally. That's not a problem. But when we're going up, we have to go no more than 2 feet. That's just building code, and that's how it works. This also ensures stability and prevents settlement. Slab specifications. Concrete slabs are typically 3 to 4 inches thick in the basement with 25 MPa strength with air entrainment. Concrete garage slabs are 4 inches typically in thickness, 32 MPa with air entrainment. Porches, they usually come in 8-inch thickness, so a 2 by 10 is perfect for forming them. They'll come in an 8-inch thick, with a broom finish to prevent slipping and tripping in the winter months. Wall bearings, they require a minimum of 3 inches on foundation walls, so you cannot have a sill plate be on the top of the foundation wall at 2.5 inches. It just will not meet code. It has to be on at least 3 inches, and a 2x4 is 3.5 inches. So you're only allowed a 1/2 inch give on a 2x4 plate before it becomes code uncompliant, and you have to usually use a lintel of some sort, an iron lintel, to support that plate in order for it to meet code. Getting back to porches, porch slabs should include always a broom finish for traction and proper lintel support underneath, especially when you have cold cellars. The sunken boom detail that we have on lot 75, a key feature. In this situation, we have a sunken mudroom at the back of the garage. This drop was necessary to allow for stair installation and interior access. Without it, that access to the back of the garage would not be possible. You'll also note that I've drawn an X where it says unexcavated area in garage. Reason for this is that this is just not the way to work properly or safely. If we left fill inside the garage, even halfway up, the form workers would not be able to work around to form the inside of the garage. There's risk of cages collapsing and a risk of the material collapsing inside the unit itself. So this is a major safety hazard, so this is not standard practice. Anywhere where it says unexcavated at a garage or a porch, we always excavate that material. And finally, we have our builder notes, which you can read at your leisure at any time. Enjoy, and I hope you enjoyed this episode. Thank you. I will attach all of these files onto a pinned link at the top of the comments. They'll include blown up versions of all the details that we went over on our construction notes, as well as all the images and everything that went with it. I hope you enjoyed today's episode, and I hope you learned something today on Foundations Are Us, where we build knowledge from the ground up.